The second section, which is 10.2, guys, is test. It's called test for independence. And in this section, you will be able to test whether two variables are related or not related. For example, someone has asked you, is there a relationship between the gender and the time a person, spent online, on social media, for example? So does it matter if you are male or female and the amount of time, that you spend, just online? This is an example of an independence test where we have two variables. The first variable is whether you are male or female, and the second variable is how much time do you spend online. And then we can use this test, guys, to determine if there is a relationship between the two. I'm going to show you another example here that we will be working on in a second. You have a blood pressure that is either low, moderate, or high, and whether a person exercises or doesn't exercise. We want to study if there is a relationship between blood pressure being low, moderate, or high, or the fact that the person exercises or does not exercise. It's for people over the age of 50. That's an example that we study. Let me show you another one. A food services manager for a baseball park wants to know if there is a relationship between the gender, male or female, and the preferred toppings on a hot dog, the condiment on a hot dog. Does it matter? Do male prefer, different condiments, just than women? We want to study if there is a relationship between gender and what kind of condiment, just people would choose for their hot dog. That's another example on relationships. So in summary, guys, if you want to study if there is a relationship between two variables, if whether they are related or not related, you do what we call the independence test. Okay. So I'm gonna start with an example and I'll show you how to perform the test. The thing about this test, guys, is the test statistic is exactly the same formula as section 10.1. So this is the formula for the test statistic. You will always be given the observed values and you have to find the expected values. But the good news with the technology that we'll be using, the calculator can compute the expected values in the background. We don't even have to compute them for this test. All you need to enter for the calculator, key in the observed values, and then the calculator will do the rest. We'll find the test statistic, which is called chi-squared, and then we'll find the p-value. And then based on the value of the p-value, guys, you make a decision to reject HO or fail to reject HO. The observed values, guys, will be in this format right here. These are called the observed values. Just like the table when we did conditional probability contingency table. Like the 35 here, guys, stands for people with low blood pressure and exercise regularly. The 65 stands for people who have moderate blood pressure, but they don't do regular exercise, and so on and so forth. The 236 here stands for the grand total. And if I just take you to the second table and show you the observed values, these are the observed values here. Male who use ketchup, male who use mustard, male who use relish. Total are not count, they don't count as a part of the data set because we did them by hand. This is your data set. So you get 1, 2, 3, 4, 5, 6 observed values. You're gonna learn, guys, how to enter the observed values. So I'm gonna walk you through the steps, step by step, and how to perform the hypothesis test for this. I'm gonna begin with the first exercise, which is example 3, which is a medical researcher is interested if there is a relationship between adults over 50 who exercise regularly and whether their blood pressure will be low, moderate, and high, depending on whether they exercise or not. A random sample of 236 adults over 50 is selected and the results are given below. Test the claim that regular exercise and low, moderate, and high blood pressure are independent. Okay, well, before I do that, guys, let me show you how to state the null and the alternative hypothesis. I'm going to show you the generic language that you put there. And don't change it ever. This is it. Variables are independent. And any guess what do you think the alternative will be? Variables are dependent or related. Now, if you do this online, you might not see the variable, the word variables. You might see what the actual variable are, which it says blood pressure, just type and regular exercise. So here you just says blood pressure and regular and exercise are independent. A blood pressure and exercise are dependent. Okay, so always the independence falls in the null hypothesis, guys, and the dependence falls in the alternative hypothesis. Please don't mix the two up. That's always the standard right here. Next, guys, I'm going to show you how to find the test statistic, which we're not going to do any work. We're just going to show you how to use technology to do this. Rather than doing a table and doing all of this work, I would just like you to pay attention to me doing this. Okay. The calculator requires that I enter the data, the observed values at the same way, just they are displayed right here. So I have to enter them as 2 rows and 3 columns. I don't know if you use this calculator beyond what we did and you know what I'm referring to. There's a feature on the calculator that would display those values in a table format. Do you guys know what we call this feature? Starts with an M. Have you guys ever heard of a matrix? What a matrix is? A matrix is an array of values that's just like a table with rows and columns, and we're going to be using a matrix. So in order to access matrices, guys, you just have to press the second key first. And then I like it to press where it says matrix here above X inverse. So it just press this. Then you go to edit. And then press enter. Okay. How many rows and how many columns? I have 2 rows and 3 columns, guys. So I need to tell the calculator that I need number of rows first 2, and then with the right arrow key, change this to 3. And all you have to do, guys, just enter the values. So enter 35. 62, 25, 21, 65, and 28. That's it. That's all you have to do. Any questions about how to display the observed values? That's very, very important. So observed values. Go to matrix A. Okay. And now watch, guys, how we're going to do the tests. Very simple now. Just go to stat. Scroll up. Can you guys tell me what do you suspect is going to be the test? We already used the GOF test. Any guess?
The X squared test?
Yeah, that's the last one, the chi-square test. This is the independence test. Called chi-square test. So we're gonna use it. See. Okay, it's telling me, are they observed in A? We say yes, we put them in A. For the expected, don't worry about it. It's gonna create the expected values for you guys. I'm just gonna put them in B. So just by default, guys, accept everything. Always accept everything. See how the curve is skewed to the right? So the test statistic is 3.474. And the p-value is 0.1761. And p-value is 0.1761. Which you agree with me, guys, the p-value is bigger than alpha, which is 0.01 here. So the decision is to fail to reject HO. And the conclusion is there is not enough evidence to support the claim that blood pressure and regular exercise are. And
Would it be reject the claim?
oh, sorry, independent. Yeah, you're right. We forgot to put where the claim is. So there is not enough evidence. Again, guys, if you're wondering why I put the claim there, test the claim, the regular exercise, low, moderate, and high blood pressure are independent. So the claim is right here. You are correct. There is not enough evidence. And the 0.01 level of significance to reject the claim. So what we're saying here, whether you walk or you don't exercise, your blood pressure could be on the low side, high side, it could go up and down, but not as a result of doing a regular exercise. There's not enough evidence at the 0.0 level of significance to reject the claim that the variables are independent. So probably the null hypothesis is true. All right. Okay, let me show you now what the calculator did for us. Actually, for each observed values, guys, there should be an expected value, just like in the previous section. So I have here 1, 2, 3, 4, 5, 6 observed values. There should have been 6 expected values. And the calculator have done them already for us, which I'm going to show you now in a second what they are. Watch. Quit, clear. All right, so go to second again. X inverse, where the matrices are. And you guys, you can see B now. B is a 2 by 3 now. It has been created for you. Just click on it, press enter twice. And one more time. And here you go, guys. You already have the expected values. The 28.9 is the expected value for 35. The 65.65 is the expected value of 62. And then if you scroll to the right, guys, you can see the third one. Then if you go backwards, you can see the second row, 1, 2, 3 values. Okay, so these are the expected values. But let me show you how the expected values were generated. Okay, what I would like you to do, guys, here for me, I'd like to give me the total of each row and of each column. So what would be the total here? 35 and 62, 90, 97, and 25, 122. And if we do that, that will be 114. And give me the total of each right there. 35, 21 is 30, what is it, 56. 62 plus 65, 127. And 25 times plus 28 is what? 53. And if you add them all up, guys, you should add up to 236, which is the grand total. Now, we assume that the variables are independent until proven otherwise. Always, guys, remember, the defendant is not guilty until proven otherwise. So you have to assume that the null hypothesis is true until proven otherwise. Remember, when two events are independent from probability chapter, if A and B are independent, the probability of A and B equals probability of A times probability of B. I would like to go here, guys, for a second. Regular exercise and low blood pressure, it will be the 35. As you can see, those two events meet right here. So let me show you how to find the expected value of 35. 35 falls at the intersection of low and regular exercise. What is the probability of selecting a person with low blood pressure? Can someone help me, guys?
56 over 236.
You got it. B, what is the probability of selecting someone who exercises regularly?
35 over 122.
No, you missed here. Not 35. Regular exercise. We don't care what the blood pressure is.
122 over 236.
Yeah.
Professor, isn't it 56 on the other one?
What is it?
Isn't it 56 on the first one? 56 over
Oh, yeah,
230?
56. You are correct. Thank you. Yeah, 56. I agree. Okay, guys. From the previous section, you learned how to find the expected values. You find the total and multiply by the percent. That's what we did. The total sample size times the percent. This is the percent here of this low and regular blood pressure. And I got this percent. And I know the total, which is 236. So if I multiply by 236 here, guys, to get the expected value, look what happens, guys. 236 and 236 cancels out. So you're left with 56 times 122 divided by 236. I would like you to compute this for me, and you're going to see that nice match, guys. 56 times 122 divided by 236. And I claim this answer is going to be exactly the same as this. Watch. 28.94915,254. That means when the calculator performed the expected values, it did them exactly like what we're doing. So guys, in other words, but you don't have to do this work by hand at all. If you are to find the expected values of 62, look what you do, guys. You take the total of the row that 62 belongs to, which is 122. And you take the total of the columns that 62 belongs to, which is 127. You multiply them and divide by the grand total. So it will be 127 times 122 divided by 236. Let's do it. And I claim it's going to be this. Watch. You get the exact same answer. So just to give you an idea, guys, of how the expected values are calculated, I just don't want you to blindly just figure it out using the matrix. This is how the expected values are calculated. For 28, to find the expected value for 28, guys, it will be 114 times 53 divided by the grand total, which is 236. So that is the first question. And let's do another question right here. A food services manager for a baseball park wants to know if there is a relationship between gender and the preferred condiment on a hot dog. So HO, guys, will be gender, or you can say variables are independent, but I'm just going to write the name of the variables. And preferred condiment on a hot dog are independent. HA, guys, will be gender, and preferred condiment on a hot dog are dependent or related, same thing. Where is the claim, guys? HO or HA?
HO. I'm sorry, HA.
I agree with your correction. HA, because it says if there is a relationship. If there is a relationship, means related, guys. And then it is in HA. Excuse me. This is where the claim is. Okay, we're going to input those in matrix A. You press second, X inverse, input data. Now let's do it. And you guys know why I crossed off the totals. I don't need him. If you're doing the work by hand, you need him, but I don't need him. So we're going to go to second, X inverse. We're going to go to edit. And well, nice. It's 2 rows and 3 columns. So that's good. Same thing. And you just do the data entries, guys. That's it. And I can quit. Go to stat. You don't need to change anything at all, guys. Nothing. If you put your matrix in A, don't change anything. Just run the test. And watch. So chi-square is 2.9479 and 2.948. And p-value is, I showed to you guys, 229. Which is bigger than alpha, of course. Failed to reject HO. And let me just move the page up and then write the conclusion. Remember, the claim is in HA. So there is not enough evidence at the 0.10 level of significance to support the claim that there is a relationship between that gender and preferred. I didn't think that it has to do with male, whether being male or female, whether you pick ketchup or put ketchup or mustard or anything on a hot dog. The gender, I don't think it matters here. And that's what we concluded. There is not enough evidence to support the claim that gender and preferred condiment on a hot dog are related. Any questions, guys, about example 4?
So if we wanted to find the expected values for this one, the female column would be the number 2 option, right? I mean, the female row.
Yeah. So let's say you want to find the expected values. You have 6 expected values here. Let's say you want to find it for 15. What would it be for 15?
Let me see. Go to 1A. See, I click it, and then it's giving me the values that I inputted.
Oh no, we don't want that. No, let's say you want to do it by hand. If you can do it by hand, look how do you do it, Ali. You take 40 multiply by what? 48 and divide by 100. So what's 40 times 48 divided by 100? But I'll show you the expected values if you don't want to do them by hand. So 40 times 48 divided by 100.
19.2.
19.2. Let's do the second one. For 23, it will be 42 times 48 divided by 100. For this one, but if you want to see him, watch. Look how do you see him. Press second, press X inverse right here. Go to B, not A. A has the observed values, B the expected values. Press enter twice. Enter, and here you go.
Okay, I was picking A the first time. Now I got it.
A has the observed values. B has the expected values.
Got it. Thank you.
Got it, guys? That's so you can see, you can get all those values without doing any work. The calculator can take care of that. Okay, let's see. All right, so I'm gonna move to the one more question from section 10.3, and it's gonna be 10.2. It's gonna be from the book, guys. I do one from the book. All right. Performing a chi-square test. Okay, I like to do number 21, page 545. So take a note, guys, we're doing this exercise, 545. Borrowing for college. Let's see what this question is about. The contingency table shows a random. So you guys, once you see a table like this with rows and columns, right away you can forward your thinking to independence test. It's going to be an independence test, of course. I will give you the table in this format. Once you see it, you know it's chi-square test. Contingency table shows a random sample of white, black, and Hispanic college students based on whether their families borrowed money to pay for their college education. At alpha equals 1%, can you conclude that borrowing money for college and race are related? So, page 545, number 21, HO. Variables are independent, or you can say borrowing money and race are independent. HA, borrowing money for college, only for college purpose, and race are related or are dependent. Dependent means related. Okay. He is asking if they are related, so it's the claim is an HA. I think all of you agree with this statement right here. Borrowing money for college and race are independent. Borrowing money for college and race are dependent. And he's asking us to check if they are dependent. What do you guys think? Do you think borrowing money for college depends on what the person's family, race, whether white, black, Hispanic, etc.? Do you think the race has to do with it or not?
No.
Probably not. Okay. However, probably some people will make different claims. It could be, but let's check and find out. You think probably they're not related. Let's check. Okay, we're gonna input, just the data into a matrix, and let's see how many rows and how many columns. Can you tell me, guys, how many rows and how many columns do we need?
3 by 2.
Yep, you got it. 3 rows, 2 columns. I agree. And let me explain to you why. 1, 2, 3, 1, 2, 3 by 2. Excellent. Let's go to the calculator. See how useful technology is. Otherwise, if you were going to do this by hand to find the expected value, guys, and then you find the test statistic doing O minus E squared, etc., it's a lot of work. So we're saving all of this. Okay, so we're gonna go to A. Oops, sorry, second X inverse, not A edit. You have to change it. So enter. So as you said, 3 by 2, so that's a 3, and I'm gonna change this to 2. All right, guys, and let me just input the values, and I don't need the book after that. So 49 and 64. Please check the screen as you enter the values. You don't want to mess up here. 85, 123, 85, and 180. Okay. I guess I no longer need the book here. Okay. And guys, now you go to stat and tests. Scroll up and chi-square test. Okay, everything is in place. Just hit calculate or draw. You want to see calculate? I can do calculate for you here. So chi-square is 5.994. P-value. I'm sure guys are gonna miss the p-value after the semester is over with. Been talking about it for a while. And what is alpha? I think I need to check in the book for alpha. It's 1%. Oh, that's bigger than alpha. Fail to reject HO. And there is not enough evidence at the 0.01 level of significance to support the claim. We cannot support the claim, we're saying, that borrowing money for college and gender are related. borrowing money for college and gender. So you guys thought that they're not related, and we ended up proving that they're not related. That is how you perform an independence test. Just for your information, guys, the degrees of freedom for the goodness of fit is number of categories minus 1. The degrees of freedom for independence test is this formula. It's number of rows minus 1 times number of columns minus 1. So in our case, guys, if you want to figure out the degrees of freedom will be 3 minus 1, which is 2. 2 minus 1, which is 1. 2 times 1 is 2. Degrees of freedom will be 2. But you don't need to provide the degrees of freedom when you perform the chi-square test. Any questions, guys, about the independence test? So what you learned today in section 10.1, you learned how to perform the goodness of fit test when you have more than 2 proportions. And you learned in section 10.2 how to test if 2 variables are related or not related. We have one more section that we're going to do today, which is probably the easiest of all. It's section 10.4, and I'm going to start talking about it in a second. I'm going to give you a 5-minute break, just before we do section 10.4.